Today, we are counting the number of occurrences of characters in a string, finding out which two integers in an array add up to a desired sum. We are validating IPv4 addresses using a regular expression, and then we are generating hashtags. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later on in the episode, starting with a function that returns the additive inverse of each number in an array. Let's go ahead and get started with this one here. Alright, const invert. We have an array of numbers as our argument here, and what we're going to go ahead and do here, we're going to run this array through map. And in the predicate function, we're going to take the number, and we're going to use the unary negative number to invert that number. In other words, if number here is negative, this will return a positive, invert it into a positive. And this, if the number here is positive, this will invert it into a negative. All right, let's go ahead and punch this into Codewars here and see what that looks like here. And we are good on that. The next warm-up kata, we are given an array of integers, and we have to return a pair in which the first element is the number of all of the positive numbers in the given array, and the second element is the sum of all of the negative numbers in the array. Let's go ahead and give this a try here, shall we? To count positives, some negatives, and we have an array of numbers as an argument here. And what we'll go ahead and do, we'll take this array and run it through the reduce method. Alright, we have our accumulator and our value, and we have an initial accumulator of a pair, which the first element is, and which both of the elements are 0. And what we'll go ahead and do here is, in our predicate function body, if the value is greater than or equal to 0, I believe, then we can actually, since we're working with a pair here, we can actually use a destructure here to explicitly pull out the positive count and negative sum. Alright, anyway, if the current value is set to 0, we can go ahead and increment the positive count. Otherwise, we add the current value to our negative sum. Alright, before we go ahead and submit this, let's go ahead and see what this looks like in our example here. Console.log, count positive, sum negatives, we'll pass in our array here. Let's go ahead and feed this in a node and see what that looks like here. Warm up count and sum. Undefined is not iterable. Okay, looks like we actually cannot do that here. So what we'll go ahead and do, we'll have our accumulator here. Alright, let's try that again. Cannot read property 0 of undefined. Okay, we have our pair here. We have our array pair here. Why can we not do that? Let's go ahead and console.log our accumulator here and see where we're going wrong. Oh, yes. Okay. Now I know where we're going wrong. We can go ahead and do this destructure here. Positive count, negative sum. We just need to go ahead and return that at the end here. Let's try that again. I guess not to. We can get rid of this console.log here. And we have the number of positive numbers in our array, 10, and the sum of all of the negatives in our array, minus 65. Let's go ahead and punch this into Codewars and see what this looks like here, shall we? Alright, what's going on?
Okay, it's...
Alright, let's go ahead and examine this array and see where we're going wrong here. Alright, let's go ahead and grab this array here. Alright, let's go ahead and grab this array here. We're going to see where we're going wrong here. We have the count of 42 and minus 2006 for our positive count and our negative sum, respectively. Let's examine all the numbers in this array and see where we're going wrong. Okay, we do have a 0 in this array here. Okay, let's get rid of that greater than or equal to sign here. Alright, still problems. Cannot read property reduce of null. Alright, we actually are going to need to do this in a function body here. Alright, we're going to go ahead and take this here, return this in the function body here. Looks like we're actually going to need to check the type of this array here. If array is equal to false, if there was not an array passed in here, we can just go ahead and array.length is 0. So we actually need to check the validity, of the array we're passing in. We need to check to see if it is an array and its length is greater than 0. If any of these two return false, we just go ahead and return an empty array here. Alright, let's try that again here. And we are good on that. Our next warm-up kata, we are taking an array of characters and we are appending a number and a colon before that letter. We have to write a function which takes a list of strings and returns each line prepended by the correct line number. Let's go ahead and get started with this one here. Const number equals array. We pass an array to our Kata solution function here, and what we'll go ahead and do with that is we're going to return array.map we're going to pass in our string, but we're also going to pass in our index here as well. And what we'll do with that is we're going to return in a template literal index plus 1 colon and then our string. And this is not necessary here. Let's go ahead and punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up kata, okay, excuse me. Our next warm-up kata, you might recall in a previous episode of Versus Codewars, I was talking about the sigma notation, which basically defines a sequence of numbers with a begin, ends, and a step. So our goal of this kata here is to make a function that returns the sum of a sequence of integers defined by 3 non-negative values, begin, end, and step. Let's go ahead and give this a try here. Alright. Const sequence sum. We take a begin, an end, and a step. And what we'll go ahead and do with that, let's go ahead and keep track of, first we need to do a little edge case here. If our begin step is greater than our end step, we just return 0. Alright, what we'll go ahead and do here is, we'll keep track of our result here, and that's what will be returned. We'll do for let index equal begin. Index, I think, is less than step, and I think, and then index plus equals step. And then what we'll go ahead and do is we'll increment our result by the index. Alright, let's go ahead and test this out here, shall we? Console.log sequence sum. We'll pass in 2, 2, and 2 at first. Speed this in a node and see what that looks like here. Warm up sigma. And we have our 2 here. What about 2, 6, and 2? We have 12. Alright, what about 1, 5, and 1? We have 15. And what about 1, 5, and 3? And we have 5. Alright, let's go ahead and punch this into Codewars and see what that looks like here. And we are good on that. Finally, we are writing a function that sums up all of the multiples of 3 and 5. Let's go ahead and give this a try here. Const find sum. Alright, we are looking for the sum of all multiples of 3 and 5, up to and including the number that we pass in here. Alright. Let's go ahead and keep track of our result again here. And return it. And what we'll go ahead and do is for let index equals index equals 3, because that is the first number of our sequence that would be divisible by either 3 or 5. Index is less than or equal to n plus index. And what we'll go ahead and do is if index, the remainder of index divided by 3 is 0, or the remainder of index divided by 5 is 0, we go ahead and add that index to our result. Alright, let's go ahead and test this one out here. Console.log find sum. Let's pass in 10 here. Let's feed this in a node and see what that looks like here. And we get 33, which is the expected result. Let's try 5. we get 8, which is another expected result. Let's go ahead and feed this into Codewars and see what this looks like here. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. In the second warm-up kata, I ran into 3 different snags here. The first snag was, for the sake of this kata, I was assuming that 0 would be a positive integer, and I was incrementing the positive count in the reduce method's predicate function whenever that function ran into a 0. Nowhere in the kata instructions did it explicitly mention that 0 would not be a positive or a negative number for the sake of this kata solution. The second snag I ran into was forgetting to check the validity of the array that was passed in. I went ahead and did 2 checks here. I checked to see if whatever was passed in was actually an array, and that the array was not empty. If either of these checks returned false, I would return an empty array. The third snag I ran into is, whenever you are working with the predicate function in the reduce method, make sure you return something in order to update the accumulator. Otherwise, the accumulator will end up being undefined in the next iteration of the reduce method's predicate function. Given a string, the goal of this kata is to return an object mapping the number of times each character occurs in the string. Let's go ahead and give this a try here. First, we'll go ahead and make up a result object here. Actually, I have an idea. What we'll go ahead and do actually is return. We're going to go ahead and split this into its individual characters here. And then we'll do a call to the reduce method here. We'll have an accumulator and our character here. And our initial accumulator here will be an object, an empty object. And what we'll go ahead and do is in our reduce method's predicate function here, we'll go ahead and return the following. We'll spread out our accumulator, and then we'll have our character here. I really don't think that's gonna work here. We need to encapsulate. Whenever you're using a one-line arrow function and you're returning an object from it, you need to encapsulate that object in parentheses, because if you don't, JavaScript will end up confusing this as the start of a function body, and we do not want that. Alright, anyway, let's go ahead and test this out here. Console.log count. We'll pass in ABA here. Let's run this through Node and see what that looks like here. Yeah, let's try that again here. We have 2 instances of A and 1 instance of B. Let's try some other test cases here. How about a blank string? Now the kata instructions mention counting characters and not specifically letters, so I think this ought to be good. Let's punch this into Codewars and see what this looks like. And we are good. Not really much anything to say about this one. But here's a little tidbit about ternary conditional operations in JavaScript. You don't necessarily need an assignment to be able to use it. For instance, you could use a ternary conditional operation checking to see if a variable like a, for instance, was set to 1. And if it was, you could run a console log a, or you could run a console log b if it was not. Given an array of integers, the goal of this kata is to return the indices of two integers in the array that add up to a desired sum. Let's go ahead and give this one a try here. First, let's see if our numbers array is empty here. Just go ahead and return -1, -1. And at the end of this here, we'll just go ahead and return -1, -1. Alright, we'll have a little bit of a for loop here. For let first index equals 0, first index is less than numbers dot length plus first index. And our second for loop here, we'll do for let second index equal first index. Second index is less than numbers dot length plus second index. Alright, so we've got a nested for loop here. Alright, and what we'll go ahead and do, we'll go ahead and grab the integers at these two indices here and add them together and see if they add up to our target. If numbers at first index plus numbers at second index equals out to our target, we'll go ahead and return a pair with our first index and our second index. Alright, let's go ahead and console.log test this out here and see what that looks like. Console.log to sum, pass in 1, 2, and a 3, and then we'll pass in our desired sum, which is 4. Let's speed this into Node and see what that looks like here. Node to sum. Alright, we have our pair of the two indices of the numbers that make up 4, which is 0 and 2. Let's have a look at some of our tests here. How about this one here? Let's pass this in here. Sounds about right. Alright, let's go ahead and punch this into Codewars and see what that looks like here. I can't say how large the arrays in our tests here will be. Let's just go ahead and find out here. But first, we got a problem. 0, 0 to deeply equals 0, 1. Alright, let's go ahead and console.log our numbers and our target here. Do the same in our Kata solution here. Okay. Let's try adding 1 to that here. Yep. Alright, that's good. Let's go ahead and try submitting this here. Again, I can't say how large the arrays here I hope we don't time out. And we do not time out, we are good. The instructions for this particular kata explicitly mention that all of the inputs will be valid. In this particular case, numbers will be an array of length 2 or greater, all of the items will be numbers, and target will always be the sum of two different items from that numbers array. However, it's always a good idea and it's good programming practice to validate what you're passing into your functions here, because there will always be that off chance that something will slip through the cracks. You could have an empty array, for instance, or an array of integers such that no two of the items therein will add up to the desired sum. You always gotta be on the lookout for that. Given a string, the goal of this kata is to check to see if that string is a valid IPv4 address. Let's go ahead and give this a try here. We are going to use a regular expression to be able to detect this IP address here. And what I think this will consist of here, we're going to go ahead and have our caret and our $sign to indicate the beginning and the end of the string. What I think we'll go ahead and do is, I think it's something like this. And what I think I'll go ahead and do is 250 to 5 or 2 4 2 0 to 4 and 0 to 9. Or I think it's one question mark 0 to 9 0 to 9. Yeah, I think that's how it goes. Or maybe, and finally 1 to 9 question mark 0 to 9. Yeah, I think that's how it goes. Let's go ahead and copy this over here to our other 3 octets here. And here's our quite long IP address regular expression here. Alright, let's go ahead and test this out on some addresses here. Alright, we will go ahead and do that by doing this. console.log, and we have we'll have an array of strings with some valid and invalid IP address strings here. Alright, bear with me a moment and let me go ahead and get this set up here. Alright, we're going to go ahead and do console.log is a valid IP. I'm not going to pass in anything right now. Just testing things out here. Let's go ahead and feed this in a node and see what that looks like here. I'm gonna map it to ipregex.test. Compatible receiver called on within or undefined. If I'm not mistaken, that takes a string as an argument, right? Okay, I have another idea. ipregex console.log ipregex.test 1.2.3.4. Let's try that. And we got true. Let's try another IP address, 123.45.67.89. We have true. Let's try some more invalid ones here. 1.2.2.3. False. Let's try 1.2.3.4.5. This should evaluate to false. Let's do this one. 123.456.78.90. This should evaluate out to false, because our regular expression here makes sure that our octets will be between 0 and 255. How about 123.045.067.089? This should equal out to false here. Alright, what we should go ahead and be able to do from here is return ipregex.test. We'll pass in our string here. Let's have a look at some of our tests down here. This very obviously should return false. And it indeed does. How about this one? How about this one here? I think we might be good to go here. How about this one here with the space? Yep. How about this one here with the new line character? Yep. Okay, I think we're ready to go here. But before we submit this over to Codewars, let me explain what this regular expression is doing here. Alright, we have these 4 capture groups right here separated by dots. Alright, what we're trying to do here, in each of the capture groups here, we check to see if the octet starts with 2, 5. In which case we look for the number 0, any number between 0 and 5 for the third digit. If the first digit is a 2, we check to see if the second digit is between 0 and 4, and if the third digit is between 0 and 9. Or if the first digit is a 1, if the first digit of the 3-digit octet is a 1, we check to see if the second 2 digits are between 0 and 9. Otherwise, if there are 2 or fewer digits, we check to see if the first digit is a 1 through a 9, if it exists. And then we check to see if this last digit here, or the sole digit of the octet, is between 0 and 9. And then we check for the dot separating each of the octet. We repeat this for the other 3 octets of our IP address string. And at the beginning and the end of the regular expression, we have the caret denoting the beginning of the string, and then the $sign at the end of the regular expression denoting the end of the string. That way, this returns false if there are any leading or trailing spaces, or any other characters other than numbers. Alright, let's go ahead and feed this into Codewars and see what this looks like here. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. In our Kata solution, we used a regular expression, a rather complex one, to test to see if the string passed in was a valid IPv4 address. Here is another way to do just that same thing without using regular expressions. Take the string passed in, use the split method to split that string into its individual octets using a dot separator. Run that resulting array through the filter method. In the predicate function, convert the string into a number that removes the trailing zeros, and then convert that resulting number back into a string. Compare the two strings to make sure there are no leading zeros. If there is, we return false. And then convert that string back into a number and check to see if it's less than 256. Our octets need to be between 0 and 255. Take the resulting array from that call to filter and check to see if its length is exactly 4. If this is true, then we have a valid IP address. Here is a hashtag generator. Given a string, the goal of this kata is to convert that string into a hashtag according to the following rules. The final string must start with a £. All words must have their first letter capitalized. If the final result is longer than 140 characters, return false. If the input or the result is empty, return false. Let's go ahead and give this one a try here. First, let's handle the edge case of an empty input here. If string is empty, return false. Next, what we'll go ahead and do is of a string called one word, and what we'll do is we'll take the input string, split it into its individual words with a space separator, and then we'll run that through reduce. We'll have our accumulator and our word. We'll just go ahead and concatenate that word into our accumulator, which will start out as a blank string. And what we need to do here is we'll take the first character of our word and convert that to uppercase. And then we'll get to the remaining letters of our word by doing word.slice1. Alright, we now need to check to see if we can actually rename this hashtag. And what we'll do is concatenate that result with a £sign at the start. Alright, what we'll go ahead and do, we need to do some additional checks here. If hashtag is just equal to a £sign, or hashtag dot length is greater than 140, we return false. Otherwise, we can go ahead and return the hashtag. Alright, let's go ahead and test this out here. Oh, wait a minute. You see this one with multiple spaces here. I have an idea of how to deal with that, but first, let's go ahead and test this out here. Console.log generate hashtag. Let's first try this string out here. Alright. Hello, thanks for trying my kata. Let's feed this in a node and see what that looks like here. Cannot read property to uppercase of undefined. It would probably help to trim our input here first. And we get the hashtag, hello there, thanks for trying my kata. Alright, let's go ahead and try another string here. A more questionable looking string with a lot of white space. This hello world here. Sure enough. Alright, whenever you're splitting strings with the split method, particularly when you're using like a blank space separator here, if you have instances with a lot of blank spaces here, white spaces, consecutive white spaces here, you're going to have instances where you're going to have blank strings. What you can do in that case here is we can run the resulting array from the split method here through the filter method. We'll pass in a word as our predicate function here, and we'll filter out any blank spaces here, like so. Let's go ahead and give this a try here. And we have the hashtag hello world, and we love to see that, do we not? Now, just to be sure that no leading or trailing spaces is being returned here, let's go ahead and encapsulate this return in some single quotes. And sure enough, it is not. Now, let's go ahead and, whoops. Let's go ahead and try passing a blank string in here. Let me get false. Let's try some of these tests down here. How about a.repeat 140? I expect this to return false, and it does. I think we're good to submit this. Let's try punching this into Codewars and see what that looks like. And we are good. Not really much to say about this one. However, instead of using the filter and reduce methods here, what I could have done better was, after splitting the string into its individual words with the split method, running that resulting array through the map method using a predicate function that capitalized the first character in each of the words while ignoring the blank strings, removing the need to use the filter method to filter those blank strings out. I could then have taken the resulting array and joined them together with a blank string separator and then prepended the pound sign to that resulting string. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.